What if I told you that the secret to feeding 10 billion people lies in the weird world of quantum physics? Picture this, it's 2035 and you're walking through a farm where crops use 90% less water and fertilizer, yet produce more food than ever before. This isn't science fiction. This is the quantum revolution in agriculture, and it's happening right now. Here's something mind blowing. We make fertilizer today exactly the same way we did in 1909. While we've put supercomputers in our pockets, we're still using a century old process called Haber-Bosch to create the fertilizer that feeds half the world's population. This process is an energy monster. It devours 1 to 2% of the world's entire energy supply, requires temperatures hot enough to melt copper, and pumps massive amounts of carbon dioxide into our atmosphere. Meanwhile, tiny bacteria in soil perform the same nitrogen fixing magic at room temperature using nothing but quantum mechanics. Nature solved this problem billions of years ago. We just haven't been smart enough to copy her homework until now. These microscopic organisms use quantum coherence and entanglement to break apart nitrogen molecules with incredible efficiency. Here's where quantum computing changes everything. Classical computers speak binary, ones and zeros on and off. But quantum computers speak the same language as nature itself, using quantum bits that can be both 0 and 1 simultaneously. It's like the difference between having a conversation through a translator versus speaking the same native language. Scientists at Microsoft, IBM, and Google are already using quantum computers to model the enzymes bacteria use for nitrogen fixation. They're not just trying to understand how these molecular machines work, they're designing new catalysts that could be even more efficient than anything evolution produced. I imagine fertilizer production that requires 90% less energy, powered entirely by renewable sources. This isn't just about making fertilizer cheaper, it's about fundamentally reimagining our relationship with the chemistry of life. But quantum computing's impact goes far beyond fertilizer. Today's farms generate massive amounts of data from thousands of sensors, monitoring everything from soil moisture to plant stress. Quantum computers can analyze soil conditions, weather patterns, plant genetics, and market projections simultaneously to determine the perfect strategy for every square meter of a farm. The result? Farming that applies exactly what's needed, when it's needed, where it's needed. Today, agriculture produces 24% of global greenhouse gas emissions. Quantum enhanced agriculture could flip this equation entirely. Instead of being part of the climate problem, farming could become part of the solution. Imagine farms that actually remove more carbon dioxide from the atmosphere than they produce. More efficient fertilizer production, precision resource use, and quantum optimized soil management could turn farms into carbon sinks. Let's be realistic about timing. Quantum computing is still early stage, like personal computers in the 1970s, but the progress is accelerating rapidly. Quantum enhanced agricultural analytics could be commercially viable within 2 to 4 years. Quantum designed catalysts for fertilizer production might take 5 to 7 years. The quantum computers that will revolutionize agriculture are being built right now. We stand at the threshold of a new agricultural renaissance. From quantum designed fertilizers that work at room temperature to crops that photosynthesize with unprecedented efficiency, the future of agriculture is being written in the language of quantum mechanics. The quantum harvest is coming, and it's going to be beautiful.